and we'll start here, and we'll just sort of formalize what we saw in 4.1. And we're going to start with adding functions. So we already talked about the fact that we just add the y values. Now, notation-wise, so this is new, there is what I call the nice notation, which is this. If you want to add two graphs, f of x and g of x, you just write it as f of x plus g of x. And since f of x means y values and g of x means y values, this makes sense that you're just adding the y values and the x value stays the same. The not nice notation, sometimes they write it like this. I don't know why. They write f plus g of x. Anytime you see the not nice notation, I would suggest changing it to the nice notation, f of x plus g of x. But you could be asked questions like, what is f plus g of 2 on your exam? And it seems like they always, just to see if we taught you, choose to do the not nice notation. Because I think you'd have no problem if they said, what's f of 2 plus g of 2? Do that first. Well, f of 2 on my graph here, f is the red graph, f of 2 is right here, that's 2. And g of 2, that's on my blue graph, that's right here, g of 2 is minus 1. What's 2 plus minus 1? It's equal to 1. And if we look on our green graph, sure enough, we have the point 2 comma 1. We're just adding all of our y values together. Can you see yourself getting confused, though, if you saw this notation? What's f plus g of 2? Okay, so we have to be aware of this not nice notation and change it to the nice notation, and then you'll have no problem. Okay? Again, since the red graph starts at minus 2, does it make sense that our green graph starts at minus 2? Because you can't add if you don't have anything to add to. It's not 0, right? You're not just adding 0. If you're adding nothing, a nothingness, the graph doesn't exist. So they want to point out here that the domain of f of x was bigger than 2. The domain of g of x was everything, but when you add them, it only exists when they both exist, so then adding them would also just be where x is bigger than or equal to negative 2. That's adding functions. You think there's going to be a not nice notation for every single one? Absolutely. So next, subtracting. We got our highlighter. Subtracting functions, we have the nice notation and the not nice notation. So chances are you'll get a question on the exam that says, can you find f minus g of 2? You would first say, well, that's just f of 2 minus g of 2. And f of 2 on the red graph was 2. And g of 2 on the blue graph was minus 2. And if I subtracted them, I would get 3. And sure enough, on the green graph, we have the point 2 comma 3. And you could do this with all of the points, just add the y values and get the results. Again, domain and range, same idea. Since the red graph doesn't exist when x is less than or equal to negative 2, the green graph doesn't exist when x is less than negative 2. And again, adding and subtracting strategies is just add or subtract the y values. When we get to multiplying, which we have right here, they have so many not nice notations. I've seen this. Wow, that's not nice as well. So there's the dot. I have seen that's really not nice. They tend to use different fonts of X's when they do this. So the one X is like thin, so it looks like a times sign, and the other X is like, has like serif, so you can tell that the X's are different. That's really not nice. Sometimes they don't put the dot. Just FGX. Any of these ones, if you see them, change it to the nice notation first. Okay? Oh, the first year that they put not nice notation on the exam, some teachers had never taught the not nice notation, and then they were not very happy. Because if you see something weird and the first time you see it is on an exam, how do you feel about that? Not very good, right? You're like, ah. That's when people can, go to the make up math strategy. You just make something up and hope that you're right, which usually doesn't work out very well. So again, here we're just multiplying the y values. And strategy-wise, I definitely would highlight those points. Because whether the red graph or the blue graph is 0, when you multiply by 0, it's going to work out fine. Yes?
So, for like all the kids taking an exam, like the ones that actually raise their hand to ask a question, was the teacher allowed to?
No, it's not. So there it's sort of like, you hope that your teacher has like read through the curriculum, but anytime that there's a new exam, there's always a little bit of that chance. Now, what they did when they made the new exam, the first year they made the new exam, they made the exam only worth 5% of your final mark. So it's a little bit more fair to students that way, that it wasn't. But then the problem is how much did students study once they found out the exam was worth 5% of their mark? Not as much. And then they weren't as ready for university or the next year. So it's a give and take. But when they change something, that's one way that they can try to make it a little bit more fair, making the exam not worth as much. And then after the exam has happened a couple of years, and you have, how many did I give you on the website? There's like 16 old exams you can look at. Lots of opportunity to see what kind of questions could be asked. Every year there's like one or two oh, that's a little bit different. But I don't think there's been any questions that I would say, if you were in my class, that would have been unfair. You have the skills to solve even those weird ones that are a little bit different. They're not necessarily fun, but I think with your problem solving skills and what we've learned, you would be fine. No kind of notation where I've never seen that. Okay, so we talked about wherever the graph is 0, so I'd like you to highlight those points, because those are important. Wherever a graph, either the red or the blue is 1, so you see that here the red is 1, my green point is exactly on the blue graph. Because 1 times anything stays the same. Here, my blue graph is 1. Can you see that my green graph is right on the red graph at that point? So those would be important points to do. Then, of course, any points that are really nice, like this is 2 and 1, that's super easy to do. Unfortunately, the next time that the points are both nice would be here at 3 and here at -6. What's the problem with that? 3 times -6? There we go. It's just really far off the graph. So it's easy to do the multiplication, but the graph point is really far away. Oh yes, it would have worked out just perfect. So that's the multiplying one. And again, you can only have the domain where all the domain graphs are. Now they go to an example one before they do the dividing one, but I want to do the dividing one right away. So turn to page 275 and all the other ones, I think this was a mistake in the textbook. They forgot the title, so you can add the titles and we can highlight it, dividing functions. And this not nice notation comes in a bunch of different ways. I've seen that, right? We've got not nice, this is real. That's not nice. I guess sometimes they could put the dividing right beside each other like that. That's not nice. Anytime you have that though, change it to the nice notation. F of x divided by g of x. Now, you have to be very aware which one is on the bottom and which one is on the top. So first thing I would do is where the blue graph is equal to 0, you're either going to get a hole or a vertical asymptote. And if the blue graph, the only time you get a hole is if both graphs intersect at exactly the same point. So most often you're going to get an asymptote. So that would be one thing for sure that I would show on my graph. Next, wherever the red graph is 0, that would be a key point to make sure that you show on there. We talked about dividing by 1 being nice. So here my blue graph is 1. Notice that my green graph is exactly on my red graph at that point. And in purple, there's the point where the two graphs intersect. Dividing the same thing by the same thing is going to equal 1. So those would be sort of easier things to do. And then, of course, if there's really nice points, like here, they have 2 divided by a -1. That's really easy to see that that's going to be -2. And then this, we had these points, that would be easy to draw towards the asymptote. This point from here, you'd be able to say that for sure goes there towards the asymptote. The red graph is positive, the blue graph is negative. So I know that in this section here, my green graph has to always be negative. But if I was thinking about these graphs, can you see that your red graph is a square root graph? And your blue graph is a line, which is like an x to the half over an x to the 1. What happens when the degree is bigger on the bottom? You would have an asymptote at y equals 0. And so that is how you'd be able to tell this part continues like that. That's a little bit tricky, and that's what makes the dividing ones the hardest of all. So, tomorrow, you're going to bring in your reviews, and we're going to have a work period for studying for our exam. We will continue with example 1 on this then on Wednesday when everybody's back from their English exam.